Okay, so this here is actually the output of our particles. That's what we're gonna copy now to get the path to it. And let's make another cool node here, and we'll call it smoke. Make it green as well. And let's do an object merge, and there you go. So now we have, I'm really wondering what this one point is. It's following us around everywhere. You can always delete it, I guess. It's still there, isn't it? That's funny. Anyway, just ignore it. I doubt it'll even show up in our render. So we have these points, and we want to now say, I need to turn this in turn, just the way we took the debris points from before, the debris source points, and said using the age and whatnot, come up with a density to spawn particles. I now need to take these points and come up with a way using age, and in our case, also the speed of the point, to make a source for our smoke. As we often do, it's faster and more direct to just type a little small vex thing just to get exactly what we want. So what do we want? I want to have, at the very least, some of the density be as a proportion of its age, as we've been doing. So I'm going to say float age scale. So it's a float because this is not an attribute that we're going to use later outside of this node. We're just going to use it in this node, as you'll see. But for now, age scale is going to be equal to the age being fit again, like we did before, from some minimum number. So I'm going to say min age, the channel min age, so that'll be some parameter that we set to some max age. And as we often do, we're going to remap that range from 0 to 1. Or rather, 1 to 0. So remember, when the age is low, when it's 0, we want the output to be high. And as it gets older, we want the output to be low. So that's cool. And then I can say the density, so far anyway, the output density, the actual density attribute, can just be the age scale. So click this to create any parameters that you referred to that didn't already exist. So I'm just going to say 0 to 1 for now. Now we still have a visualizer on, or rather that was the color, the age color from our sim. I'm going to put an attribute delete here and get rid of that color so we don't get confused by it. So here's the visualizers. Here's the density visualizer. Remember, we made this before. So the density visualizer is showing us start hot and then get cool over the length of a second. And as you can imagine, if we bring this value down, it will get cooler faster. So that's something. Let's say maybe it shouldn't be from 0 to 1. Like maybe it shouldn't immediately start to cool down. Maybe it should stay hot for the first 0.5 seconds. See, now it's always hot. Hot, 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 hot. And then only after a half a second should it start to cool down. So now it's going to ramp down from a half a second to 1 second. Like so. So that's cool. I like that. I also know, as I said already, I want to use the speed. I feel like the faster the particles are moving, the more they're getting broken up, and therefore that's how they are dissolving further into tiny particulate that makes smoke. So I'm going to say, let's make a different thing here. Oops. Speed scale. Oh my god. Again, another fit. And what is speed? Speed is the velocity attribute, but it's not, the velocity also points in a certain direction. We don't need the direction, we only need to know the pure speed of it. How fast in any given direction is it going? And as you may already know, the length of that vector, we talk about this in particles, the particle lessons, the length of it is the speed. Basically, how long is that vector? I don't care about what direction it is. And again, we need to remap this from some minimum speed to some maximum speed. Except that this time, I want it to be from 0 to 1, because when it's not going very fast, it should not contribute much to density. And when it is going fast, it should be contributing to density. So first, before I'm going to multiply these two together. But first, let's just see speed scale. Oh, well, I didn't make these new parameters. So again, we'll do 0 to 1. So as it's moving faster than 1 unit per second, which is pretty much all the particles, it's all pretty much red all the time. Now, not the ones on the ground. This is one of the key things that we want here. I don't really want these particles on the ground to be emitting anymore. Once they're not moving, they really shouldn't be falling apart. So that's too much, though. So let's increase this to 1 to 2. So now it won't contribute anything if it's going less than 1 unit at all. And it will contribute the maximum amount once it's going as fast as that. I'm going to double that even again. So now we're really isolating these fast moving ones. And the ones that are out here aren't really contributing much, if anything at all, to the smoke. They're still generating the particles, but they're slow moving particles. So I don't feel like they should be dissolving that much. But eventually, as they gain speed, they are. And then we'll have plenty of contribution to the smoke by the end. So that's pretty much it. Now I want to actually take both into account, though. So speed scale times age scale. That should get us, well, let me back off this for a second. So there we go. So here, it was just the speed contributing. So lots of smoke getting made. But once I put in age scale, these particles are old, though. So now it's whoever's less. Like whichever one, the zeros are being multiplied in. So whichever value of these is less is going to kind of have a stronger influence. Because 1 times anything is itself, but 0 times anything is 0. So in any case, so they're multiplied together, and now we're really seeing where the hot spots are of where the smoke's going to be generated once we create our smoke volumes from this. So as we often do, let us make a flipbook and appreciate where the smoke is going to be created. And there you go. Another flipbook for the history books. And in any case, yeah, you can see all the hot areas, and that's where our smoke's going to come from. And it'll move from there with all the velocity and such. So that's what we're going for. So let's create a source. Let's start making the sources for this volume, or for our volume sim. Volume rasterize attributes, our old friend. We've seen this a bunch of times now. At least if you've been following along in the volume series, I should say. So what do we want to rasterize? Well, the density. The density attribute we just came from here. So let's find a frame, like so. And there you go. Looks like a blob. Kind of hard to see. So first things first is I like to zoom out, kind of like find an angle on it, control click the distant light, like so. And now just go back into our camera. And now we have some shadows, at least as long as we're in, one of these higher quality lighting modes, not this mode, we can at least see some shadows. We have a better feel of it. Now, it looks insane still otherwise. Voxel size, we don't quite know what we want there yet. I mean, this is going to be in terms of our simulation, but 0.1 is probably fine, actually. What we need to change is the particle scale. Particles are way too big right now. I'm going to say particle scale can probably go to 0.1, kind of near down where the voxels are, really. Well, we can keep it there for now, and we can always change it later. More importantly, though, especially when we're dealing with this first explosive stuff, we need velocity blur. We want to blur it the full length of the frame, and we want to blur backwards. So we're going to see, we want to basically drag these points from the previous frame to where they are now, and then making a volume along the way. An interesting thing you can do, well, let's also put this up to 8 to make sure we have enough samples. Interesting thing you can do is if you look like your viewport here is kind of blurry, and if you have a nice graphics card, we can put that graphics card to work a little bit. Press D in the viewport and go to the texture tab. Texture is not where you would expect to find this, but it is technically how this works under the hood. Under 3D textures, these volumes are actually sent to the graphics card as a texture. This limit resolution is what's making it look blurred, like blobby or not. Try kicking it up if you can afford it to 256, 256, 256. Now when you switch frames, you can see how it just popped a little bit. And now it's a much higher resolution display of your volume here in the viewport. So, pretty cool. I mean, you might have a volume that is greater than those things. As you can see, it's clearly greater than 256 cubed. But nonetheless, it is a much closer representation to it. So just so you know, you can do that if you have enough memory on your graphics card to support that. So that's nice. So now we have a nice velocity blurred density volume. Sweet. So moving on from that, we also need to make our velocity volume itself, because this is just the density. So I'm just going to copy and paste that one over here. I like to do it separately. So this one will be called V. Now this one is harder to visualize like this because it's showing us, you know, the positive velocity values as density, and the negative ones, which are valid, they're just moving in a negative direction. It's showing them as invisible. So that doesn't work so well for us. So let's just do a volume slice. Let's chop it and then do a trail, or rather a volume trail, and have the volume trail take that slice we just made in the first input and the original volume in the second, and we've made a turn off of your actual visualizers here. And there you go. Now we have little volume trails. Here's our volume. If I click on this, I can move the slice around to find like a better slice to take a sample of. But you've seen this before in any case. We now have a velocity field that we can also source into our simulation. Some considerations we might have is I don't usually do a velocity blur on the velocities themselves. You can. It's probably not wrong, but I've often just find that it adds too much velocity, or I don't know. I turn it off, and I'm going to turn it off in this case. It's just I think a matter of taste. The actual points here that are being turned into the volume thing here, we can modify them a little bit before actually creating the final things, before creating the actual velocity volume. Like looking at this, it's all pretty uniform because the pieces, I'm sure, are falling straight down. But it could be nice to noise it up a little bit. So let's actually do an attribute noise on the points that are going to be turned into the volume. So I'm going to say, let's add a 3D vector to the velocity. And it should be animated. It should be centered, meaning that we're getting negative values and positive values. So if I disable this and turn it on again, something's happening, but we don't see that much. So I'm going to say, let's increase on here. Let's increase the amplitude. And we need to increase it in all three axes. So the higher it goes, the more impact we're seeing on it. Something like that. I'll just make it I'm going to go back down to 24, 24, 24. And we can also say the element size can be smaller, because the bigger the element size, the larger the features we're adding to it. So by making it smaller, let's make it 0.5, I'm going to add smaller features to it. So we went from this to this. So it's just a much more interesting noise. It's kind of like the atmospheric, interference, or again, the pieces are spinning around or whatever, just adding some noisiness to it to make a more interesting final result. Okay, so let's merge these two together. So we're seeing the density, but we're back to seeing this on top of it. I can do a volume visualizer, or volume visualization here, and just say, in the viewport, show me the density and nothing else. So I went from this to this. So it's still there. It's just not being displayed. Essentially, it's just invisible now. Cool. So that's pretty good. we'll probably end up playing with the voxel size here. Let's see, if we looked here, voxel size was at 1, so a little blurrier here. Now it has a little bit more resolution to capture. It doesn't look too different. But let's make the sim itself first before we modify that any further.